Hello, good afternoon. Again, this will be the continuation of the discussion I made a while ago. So basically, this will explain on how to convert uh, or how to arrive a number of possible combinations with the use of switches. Because as I said a while ago in my previous video, that binary is actually a representation of switches, since computers can only understand two state, which is the 1 or 0, or the off and on switch, which is basically what is a binary system is all about. So, so let's continue. So if you have one switch, how many possible combinations? So it has two possible combinations. Why? This is actually how it goes, or how we come up with the possible combinations of two with the use of one switch. So number of switch, we have one. Status, we have on and off. So as I've discussed a while ago, that when the switch is turned on, meaning to say the binary equivalent for that will be 1. And then when it's turned off, the binary equivalent will be 0. So how many total, or how what is the total combination? So the total combination is 2, because on and off there are actually two possible combinations, which is the on and off. The binary representation is 1 and 0. So how about if we have two switches? This one. How about if we have two switches? I want you to try, of course, in our different homes, we have switches at the house, because that is how we are going to turn on the light in our house. So you try to practice, or actually internalize how is the possible combinations arrive into the uh, four possible combinations when you have two switches. So it is actually the same. You're just actually internalizing the number of switches in the actual scenario. So how we are able to come up with the possible combinations of four combinations with the use of two switches. So number of switches, we have two. So status, if you are going to turn off all the switches, the binary representation will arrive to 0 and 0, because off is equivalent to 0 binary. So the second possible combinations will be, you will are going to turn on the first switch and turn off the second switch. So it will arrive, or it will give you a binary representation of 0 1. 1 is on, 0 is off. Now the third combinations will be, you're gonna turn on the second switch, turn off the first switch, so it will give you a binary representation of 1 or 0. Now, if you are going to turn on all the light, meaning to say it is 1 1, so the switch is turned on, so it will give you automatically a state of 1 for the binary representation. So therefore, you can come up with the four possible combinations. So that is how actually uh, how you are going to come up with the possible combinations using the switches. Now, how about if you are going to have, or if there are three switches and you are asked how many possible combinations? Actually, this is part of your activity. That's why if you notice, I didn't put any value for the binary representation, so that you can actually solve it in your own. But anyway, I will discuss it on how you are going to uh, answer it by using the binary representation. So if there are three switches, the possible combination is 8. So why it is 8? So number of switches is 3. So if you're going to do off the three switches, it will give you a binary representations of 3 0 0 0 0. So in this example, I actually put a decimal equivalent for you to be able to understand later on that in every binary representation there is actually an equivalent for decimal. So second combinations will be off on, so it will be 001. Third combinations will be 0 on off, it will be 101. A fourth combinations, it will be off on or on off, it will be 110. And then on off it will be 100. As long as you will always remember that once it's off, the value for the binary is 0, and once it's on, the value representation is 1, 1 and 0. So if you're going to total this number of status or number of state, may it be on and off, these are the equivalent, decimal equivalent. So maybe in our next video, I will be, not maybe, the next video will be uh, how to solve or how to convert the binary representation or the binary value to decimal equivalent, and vice versa, decimal to binary, binary to decimal. So that how it is being converted to, or how we come up with the possible combinations. ASCII code will also be discussed in a different videos. So this is somewhat the same with your activities. So let's say for example this number 3, all you need to do is to put the value of 000. So let's say for example again this is 3 switch. All you need to do is to give the 8 possible combinations. So once it's turned on, it's 1. Once it's turned off, it's 0. So I hope you understand, even if I'm not really sure if I discuss it uh, with uh, with your, actually the level of understanding that you have, most especially that uh, I presume or I believe that binary is still new to you, but this is how it goes. Computer can only understand binary system. So this topic will actually, if you are going to understand this topic, this will really give you a long way, because this will be discussed again by your the next subject that you're going to have in the future. So again, if you have any questions or clarification, please let me know. Leave me a message, and then so that I know how to assist you. And I hope you learned something from this video. Thank you and have a great evening, everyone. Now, have a great afternoon, everyone.